This is Dragus Ryu. Sorry we took a few minutes getting this extraordinarily complicated streaming setup that we've got going on here, because we're broadcasting out to an air meet and several live streams. But I'm very honored to introduce a gentleman who's been coming to our conference for years. I really consider him a strong part of our community, and just a pioneer in so many ways in computer security, and he's going to tell us about a subject that I think is, I was telling him earlier, we're going to be talking about this for the next decade because it's a really important area, because the blurry boundaries between where reality is and where computers can simulate it is changing all the time, as we can see even from some of the platforms that we have here for this conference. And with that, please a big virtual hand for Peleus Uhley, and who from Adobe. And I'm going to bow out of the way and let him turn on his screen share here, and his slides, and let him tell us about deepfakes. Peleus, it's yours.
Okay, can you hear me okay? Is there any echo? All right. So I'm going to go ahead and start my screen share then. And hopefully you can see. So as Dragos mentioned, my name is Peleus Uhley. I am a lead security strategist and a principal scientist at Adobe. And what I'm going to be talking about today is the misinformation age and defending against deepfakes. And when this project came up at Adobe, this was something I actively pursued the SVPs to make me a part of, because I thought it was going to be a really interesting problem. It was going to be a really challenging problem to tackle, because unlike some issues that we have in security where it's machine against machine, this is machines targeting humans directly. And that's going to create a lot of challenges and opportunities for improvement. So, and specifically, this is a societal problem. So if you're trying to make your dent in the universe, going after problems that affect society is a good way to do it. And in terms of it being a societal problem, it's not just the deepfake technology itself. It's that even the threat of deepfakes can cause a lot of confusion and in society that can have bad side effects. So, at its core, society needs some way to determine truth in order to function. If a political leader makes a statement, we need to be able to quickly verify that statement and know that what we've seen and what we've heard is in fact true. And that's regardless of whether they're making a statement on policy or whether they're making a declaration of war. We need to be able to have some sense of truth in order to be able to move forward. Unfortunately, the world is always not that clean. You can't just say, well, if it's a deepfake and it's a political entity, then obviously you shouldn't trust it. Because one of the things that we saw was a use of deepfakes in India for political purposes, but that was not malicious. So in India, they're a country that speaks a multitude of languages, and a politician wanted to be able to reach out to a group where he didn't speak their language. So he had actually hired a deepfake company in India to generate a deepfake of him speaking to that group of people in their language. So now we have this sort of confusing situation of, well, never believe a deepfake, unless of course they intentionally created it, in which case maybe it's okay. Outside of politics, the use of deepfakes and cheapfakes have been increasing in pornography. A group called Sensitivity.ai did a report on the state of deepfakes, and it covered a lot of different topics. I just picked this particular screenshot out, and it was of a technology called Deep Nude, where somebody went and created technology that can take a picture of a clothed person and make a picture of them nude or make a video of them nude. And it was way more popular than they had intended, to the point where they took it offline and they tried to remove it from the internet, but at that point it was available on BitTorrents and other places for download. And in the report, they cite Daniel Citron, who talks about deepfake technology being weaponized against women to terrify them, to embarrass them, to demean them, or silence them. And we've seen this on other technological platforms. Reddit had to shut down their deepfake channel, as well as Twitter and Discord. And you may be thinking to yourself, well, this is something that happens to celebrities and politicians, but that's not necessarily the case. Just last month, a woman in Pennsylvania was arrested because she had allegedly created deepfake photos and videos of the rivals on her daughter's cheerleading squad. And so she created videos of her daughter's rivals smoking and drinking, and also created nude videos and sent those videos to the coaches and to other individuals in order to go after her daughter's rivals. But the part of the reason why I say allegedly is because some of the video is now being contested, where people aren't completely sure whether these were actually deepfake videos or not. And that leads into problems in the courtroom, where an article in the American Bar Association journal talked about how courts and lawyers are currently struggling with the prevalence of deepfakes and how they will affect trials and prosecutions. Because before, if you had a video of somebody doing something, that was usually pretty strong evidence, and it was almost guaranteed that you would be convicted. But in a world today where you can't trust images and video, that becomes more uncertain. And they highlight a case in a British courtroom where a woman and her husband were having a child custody battle, and she created what are known as cheap fakes as a way to win the court case. And it was found out that she had actually manufactured some of the evidence that was presented. So this feeds into how we run our courts in the US, the UK, and abroad. And then also it can just interfere with our ability to appreciate the simple things and just enjoy things in life. So recently we landed a new rover on Mars, and everybody was excited. They wanted to see the new photos and videos. They wanted to see what this new location looked like, and how good and where the camera is going to be, and is the rover okay? So there's a lot of anticipation around it. And someone knew that anticipation was there, and they went and they created Mars video and images based on data from old rovers and presented it in a way that made it appear like it was probably from the new rover. And that got retweeted tens of thousands of times. It had over 8,000 quote tweets. And basically 25.6 million people viewed it, thinking that they were going to see video from the new rover, and it wasn't. It was video from an old rover from 10 years ago, basically. And when you have these types of events, it just sort of can erode your desire to be engaged in general. So Adobe research did a survey of 1,200 people, 800 consumers, and 400 creative professionals. Adobe creates tools like Photoshop for creative professionals. So we separated them out because they're the people that are actually creating the content online. And most of these stats are roughly the same, so I'm just going to round it to 2/3. But that study of 1,200 people said that roughly 2/3 of them frequently came across fake images online. They were worried that altered images were causing people to believe misinformation. They were worried that those images would drive distrust in the news, and that the images will ultimately cause people to tune out of the news. With one person saying, if we can no longer trust the images we see online or in the news, you just get completely skeptical of everything and you start checking out. And that's bad for society. We need people to be engaged. We need people to be contributing to society and know that they're contributing in meaningful ways because they're working from real data. And this study was repeated in the UK, where we surveyed 900 people with 600 consumers and 300 creative professionals. And the stats were almost the same, with 62% of Britons reportedly that they frequently came across fake images online, 1 in 3 having seen somebody else like or share a fake image, and also highlighting that knowing the person who shared the image online doesn't necessarily instill confidence, with only about a quarter saying that it helps them sort out whether the image is real or fake. And they had almost the exact same numbers in terms of being concerned about people being misled, leading to distrust in the news and no longer taking the news seriously, and basically tuning out the news and checking out. And another topic that was covered, which was important, is how would you know? So in the UK study, about 1 in 2 people said they personally do a good job of working out if an image they see online has been altered. If it's cheap fake, they feel they can do okay with that. But they worry about, would they be as successful as these images get better and as the deepfakes improve? And a lot of them didn't feel that they necessarily had the tools or the knowledge to be able to do it if it was edited by professionals. And as a technology, the technology is out there and it's being used. So there's no putting the technology back in the bottle. For instance, Frito-Lay, the potato chip company, recently ran a promotion where they worked with Lionel Messi, who, depending on what country you come from, is either a soccer or a football star. But basically, they wanted to send customized messages to people where Lionel Messi invites you to visit the match. So you could go online, you could customize the message for whoever you wanted to send it to, and then Lionel Messi would go invite that person to the game. But of course, Lionel Messi is a busy guy and didn't have time to record all of them, so they used a deepfake company to generate these customized messages that could be sent to fans. And you can even reanimate dead relatives. So the site myheritage.com has a feature where if you have an older photo of your grandmother from when she was young, they can take that 2-dimensional image and generate a short video in 3 dimensions of them smiling and turning their head and basically staring back at you from the grave. So I think the technology is here to stay. And if we're going to have a discussion about this, there's basically 3 pieces of terminology which are useful to know to have a robust discussion about this. One is the term cheap fakes and shallow fakes. And this is basically a differentiator between disinformation that was generated using very little effort, maybe using just traditional techniques of Photoshop editing, versus things that are using machine learning. And one of the most popular shallow fakes available online was a video of Speaker Nancy Pelosi in the US giving a news conference where she appeared to be drunk. And the video of her was real. She was at the conference and she did say the words that were in the video, but all someone did was slow the frame rates of the video in order to make her appear drunk. And then that went viral online. And since cheap fakes are easier to make, during 2020, they saw a huge spike in cheap fakes online, with one company saying that they saw basically a 20-fold increase during that time, with about 60% of them being political and being distributed online. Now, for the purposes of my talk and for what I'm concerned about defending against, I don't really care how much effort you put into creating the attack, if you did it with just a little bit of effort, or whether you trained a machine learning model for 2 months to generate it. The effect that it will have on society is still the same. People will still be misinformed, and people will still start to distrust the news and be checked out from society. Another term that gets used a lot is misinformation and disinformation. And disinformation is the thing that you created that is fake. And misinformation would be sharing that piece of information to someone else where you are actively misinforming them. And there's an entire lesson plan on this on PBS's website, which in and of itself sort of speaks to the widespread nature of this issue, that PBS is creating school lesson plans to help educate people about this. And finally, the third thing I want to go over is what's known as the liar's dividend. And this is a term which was generated from a paper from Georgia Tech. It's a really long paper and goes over a lot of different aspects of this problem. And depending on who you see talking about it, they may use the term slightly differently depending on how they want to highlight the different aspects of the paper. But basically, it's the way in which an environment where it's unclear what is real and what is fake can benefit those who create and spread fakes. And it can also benefit politicians who, for instance, have a video that comes out of them that is actually true, but there's a benefit for the politician if they label it as a deep fake or a cheap fake. So some examples of how it can benefit the politician is if you have really fervent supporters who are always out there looking to fight a battle for you on your behalf, this gives them something to go out and do to wage a war on YouTube and Reddit and Twitter, saying that this is fake. In addition, even for your non-fervent supporters, because there's this mistrust that gets generated about the news that's reflected in the Adobe research, people may give you the benefit of the doubt. They may be to the point where it's like, there's always some new allegation. Half the time these things don't turn out to be real. The news gets it wrong. I'll just give the guy the benefit of the doubt, even though the video of it was true. And that you can continue to build on this. For instance, if there's one video out there of me doing something bad, I might go and intentionally generate, let's say 19 deepfakes of me doing that thing and put those out there in the world too. That way, if a Reuters journalist goes out and tries to determine the veracity of all these videos and they pick 5, there's a decent chance that all the ones that they look at are deepfakes, and they just assume that all 20 are deepfakes, even though one of them was true. And even if one of them in the sample is the true video, if you see 4 deepfakes and one of them's true, you may come to the conclusion, well, 4 of them are definitely deepfakes, and I can't prove this other one's a deepfake, but maybe it's just a really good deepfake and I can't determine. So therefore, I'm going to assume that that video is false also. So there's all these different ways where making allegations of fake news can actually benefit the politician and create a dividend for the person who's creating the lie. It's a really good paper. They explain it much better than I do. It's interesting to go read if you're interested in this topic. So then there's a question of, how hard is it to create a deepfake? Is it what's involved in doing this? Could the mother of a cheerleader do it? Could somebody in a child custody battle do it? And the answer is there are plenty of tools online today that you can go and you can download to help you create one of these. So there's mobile applications on App Store and Google Play. Reface is just one of them. There's also Wombo, Avatarify, etc. So you can go download a mobile app. If you want to dig a little bit deeper, there is open source projects out there, such as Deepfakes Lab, which is fairly popular, for being able to do this and actually grinding it out using code and samples. They claim that more than 95% of deepfakes are created with their tool. I don't know if that statistic is true or not, but it is definitely popular and widely used. And they've been improving that project over time. So if you go look at their GitHub page, when they first started, they could only do 64 by 64. And over time, they've gotten up to 448 by 448 resolution. So it's being contributed to and actively developed. There are also open source tools if you need to be able to do voice cloning. And these tools that I'm highlighting, I'm not endorsing. I'm not saying that they're the best of the best. I just needed screenshots, and these were some of the ones I came across. And voice cloning could be interesting for social engineering. For instance, there was a story a while back that a deepfake audio was used to authorize a wire transfer of $243,000 between companies. They never caught the individual, so it's not clear whether audio was used or not. But people could try it out at the social engineering village at DEF CON as a new way of doing phone scams. And then, of course, there are YouTube videos online about how to make a deepfake video in 10 minutes. There's a lot of videos out there. A lot of them are actually longer than 10 minutes. And they do a pretty good job of, giving you suggestions about how to make the inputs such that the machine learning algorithm has to make as few changes as possible. And if the machine learning algorithm only has to make a few changes, the quality of the output will be much better. So you can go and you can watch YouTube videos about how to create these things. In addition, DARPA tried to create a map of the adversarial landscape of where things are in terms of resources and skill to be able to do this. And you can kind of see that right now the deepfake, shallow fake arena is in the lower scale, lower resource area. They're not quite Hollywood level yet, but they obviously could get there. And you could imagine them moving up the line as the technology increases and people get better at creating generative adversarial networks, which is what they're referring to in the slides in terms of GANs. So the problem's out there, the tools are out there, it's creating a problem for society. So what can we do about it? And this is where we get into defensive research. And there's a need for technology to identify deepfakes. So for instance, platforms such as Facebook have put out policies where they said that they are going to try and enforce restricting the use of deepfakes and shallow fakes online, be able to take them down. California tried to pass a law banning the use of them for political purposes. But so there's definite need to be able to go out and try to be able to identify these so that they can be taken down. But when you're working at Facebook scale, you need technology to do it. You can't just have human review when you have 3/4 of the planet uploading images every day. So Facebook decided to put their money where their mouth was, and in 2019 they partnered with Microsoft and AWS to do a deepfake detection challenge. And the competition was actually pretty successful. They had over 2,000 participants with over 35,000 detection algorithms submitted. After reviewing the results, and I think they had to disqualify 1 or 2 people based on technical issues, but the initial algorithms were able to detect at a 65% accuracy rate, which for Facebook, that's only slightly better than a coin toss. It's not that great, but it started a process, and it was a process that got built upon over time. So, one of the professors who was helping with this recently released a paper that he did in conjunction with State University, New York at Buffalo, where they were looking specifically at portraits and trying to identify deepfake portraits. And given a specific set of criteria, could get to 95%. So, the knowledge that was started here has been built upon over time, and getting that many participants involved has led to subsequent research. And another thing that came out of this, which was really important, especially if you do machine learning, is that that one of the hardest things for machine learning is getting a really good quality data set. And Facebook actually went out and hired 3,000 actors to create short video clips that could be used for training these models. So just the generation of having that data set there is a lot of value to the industry. And in fact, Microsoft used it when they released the Microsoft Video Authenticator as one of the data sets that they trained on. They also trained on other data sets like Face Forensics++. But you can see that the output from that competition lived on and continued to improve just outside of what Facebook was doing. I referenced a DARPA screenshot a little while ago, and that's because DARPA has also been looking at this. Obviously, when you're dealing with political leaders, there's national security issues. So DARPA, which is the US Defense Research Agency, has started 2 different projects to go after this type of technology. One is Medifor, or media forensics. And that is a tool that will automatically detect manipulations and try to provide detailed information about how the manipulations were performed and reason over the overall integrity of the image. So that looks at a video or a photographic asset in a bubble. I'm just looking at it by itself. But they also created a program called Semaphore, or semantic forensics. And this tries to take it one step farther, where not only are you looking at the image, but you're looking at the complete context in which the image was provided. So they talk about a multimodal asset, and a multimodal asset is a media collection that can be treated as a single event, such as a news story, and that may contain some combination of multiple modalities, such as video and images and text and audio. So they're trying to take a look at the whole picture, right? Like if this is posted on Twitter, what about or in a news story, what can the surrounding information around this image also tell us about its legitimacy? Because they're actually looking at a couple of different threats. So obviously there's the potential for targeted personal attacks, against a politician. But they're also concerned about, what if somebody takes this and tries to do generated events at scale? We've already seen where, governments and malicious groups can go out and generate hundreds and thousands of fake Twitter accounts and fake YouTube accounts and fake Facebook accounts to go and try and populate the comment section of existing content to try to sway people's opinion. So what if you take that same army of bot users and you actually have them start creating content of their own? So they create photos of an event, from different angles and different perspectives, and you add video on top of that from different angles and different perspectives. They're all deepfakes. They're all wholly generated. Can you, through that broadcast platform, actually generate an event that never happened through enough fake accounts and fake images? And then they also look at what's termed as ransom fakes, or basically identity attacks as a service. So, if there's a crime to be done and you can make money off of it, what's the potential for someone to be able to go out and start offering this as a service, creating possible fakes of substance abuse or foreign contacts in order to undermine a target. And this approach is good. There's a lot of value in it, but there are some challenges associated with these approaches. One of which is that machine learning is research that's still developing. So you probably all saw this tweet from a month or two ago about somebody attacking a machine learning algorithm and confusing it because it can't tell the difference between an iPod device that has an image of an apple and the word iPod, and an actual apple with the word iPod attached to it. So you have to be worried about the traditional problems around signature-based detections, right? It becomes an arm race between robots, where if you've ever worked as a defender, you know these sorts of problems, right? Is your defensive network technology really good at detecting attacks, or is your defensive network technology just really good at detecting Metasploit, which is not the same thing, right? Is your attack methodology generalized enough? There's questions about whether this can be detected in real time or not, to stop something before it goes viral. And while these are definitely concerns, these are still necessary. For instance, going back to the American Bar Association journal example, these things are going to start showing up in courtrooms, and there will be a need for long-term forensics analysis. So they're useful there. And they're also very useful because they can be implemented now. The technology out there is available, and we can start working on them, and we can improve them, going from the 65% in 2019 to try to get closer to 95% in some areas based on the Buffalo research. So these are good, and I think they provide a lot of value, and they're definitely worth pursuing. They are one tool that we have at our disposal. But they're always going to be fighting the uphill battle of the fact that there's an infinite number of ways to tell a lie, but there's only a finite number of ways to tell the truth. So let's say a New York Times infographic goes viral online, right? You'll have your normal pundits, criticizing it the way we see every day on TV, where the conservative side saying, "Oh, the New York Times is just liberal propaganda," and then the more liberal side saying, "No, the New York Times is quality journalism. Even if you don't agree with the conclusion they came up with, they usually do all of their stuff sorted into true facts. We can trust this image. They're good at verifying their sources." But what if the infographic wasn't created by the New York Times? What if it was just something that someone created and they slapped the New York Times logo on it? Well, in that case, you still have everybody arguing, right? The conservatives will be saying, "Hi, you stupid liberals. You fell for it because this piece of propaganda reinforced your worldviews." And then on the other side, the people will be saying, "This is why you're wrong not to trust the New York Times, because this was specifically generated to discredit it with people like you who don't check their sources. Your whole platform for hating the New York Times is based off of false information. Please quit discrediting them." Well, as technologists, we can't do a whole lot to help with the first problem. Whether or not you trust the New York Times is your decision based on your values and your reasoning about what they put out. But as technologists, we can help try to solve the second problem. We can at least try to make sure that if you are arguing over something, you're at least arguing over something that actually exists. Because this is one of the things that makes just misinformation campaigns so attractive is if you put it out there and everybody believes it, you win because everybody's arguing. If you put it out there and you get caught as being faked, everybody is still arguing. So what we want to do is we want to try to remove the problem of people arguing over things that never actually existed in the first place. And we're going to try to do that through what we refer to as provenance. And traditionally, when people consume the news and you're watching Walter Cronkite on TV or you were reading the New York Times, you got that information fairly directly. It was a fairly straight shot from the news studio into the TV in your living room. Or if you're reading the New York Times, you went to the local bodega and you bought a copy and you're reading it with it in your hands. And there were very few people that were involved in between. But if you think about how media is consumed today, a lot of people don't go to the original news source, right? We get some snippet of the overall article that someone decided to pull out of context and then put on Twitter that's wrapped in their own context. And we get the information secondhand and repackaged. And that's one of the things that allows disinformation to spread is that we no longer go to the original source a lot of times when we try to consume information. And by providing provenance, we're essentially providing a digital signature around the content. And you get all the protections that a digital signature can provide, which is you can prove the identity of the publisher because you can verify who signed it. You can ensure that what you're looking at wasn't altered before it was presented to you because you can verify that the signature of the content is valid and the hash of that content matches. And you can secure the metadata within the content. So if there's additional context about the image which is relevant, such as timestamps or GPS location, that can all be secured as a part of the content that you're looking at. And then, once that data is in there, it can be used for observational, just checking to make sure it's a signed image. It can be used for interrogational purposes, such as digging into the metadata to do some reasonable analysis, or post forensics. And basically, a lot of the ideas that I presented in this slide were first put together by Bruce McCormick, who's also working on the provenance problem within the different working groups. So I wanted to make sure I credited him because I basically stole his slide to put, and his previous content to put this together. So to create provenance, Adobe got together with Twitter and the New York Times in 2019 to create the Content Authenticity Initiative. And this initiative was to help provide building systems to provide provenance for digital media by giving creators the tools that they need to be able to sign their content, to be able to add in metadata, and for people to be able to view that information once it's in there. And similarly, Microsoft joined with the BBC and CBC Radio Canada and the New York Times on a joint project called Project Origin. And this was focused specifically around video and news. CIA is sort of general purpose. We're trying to solve a lot of use cases as a general platform. Microsoft was going specifically after media and news organizations with their project. And they created some services around this, such as what they call AMP services, which is authentication of media via provenance. And that includes a manifest database and a public ledger of the content that goes through their system. And they launched this in 2020, along with the launch of their Microsoft Video Authenticator. And if you're thinking to yourself, like these projects sound really similar, aren't they basically the same thing? Yes, in a lot of ways they are. And that's why the two projects decided to join together to create the Coalition for Content Provenance and Authenticity, or C2PA. And this is a body that's working to create common open source standards about how this provenance will be added to media and the processes behind it. And this is being done with the help of the Linux Foundation via the joint development project structure. And as an open source standards project, it has overarching goals for privacy, accessibility, simplicity, extensibility, etc. And this isn't an attempt to go and create new media types to be able to support this. This is a project that tries to add this as a feature to the existing media types that we already use every day and that we support. And as an open source project, it's not trying to require any sort of specific technologies or hosting strategies. So Photoshop will support CIA in creating CIA-enabled images. If the open source Linux GIMP project wants to do the same thing, they can. But this doesn't necessarily replace Project Origin or CIA as standards. They're the guidelines and the specifications for how to build things. Project Origin and CIA are still going to be doing some work as actual implementations of those standards. And the goals and non-goals for C2PA is basically what I referred to in that first example with the New York Times infographic. The goal is to help make sure that you can definitively prove and know that the thing that you're looking at was generated by the New York Times or the BBC or whoever created it. What this is not trying to do is tell you whether or not you should believe it. Whether or not you want to believe the information that's being presented to you, that is up to you. We are just trying to make sure that you at least know for sure that the information that you received was in fact from the group that you believe published it. Because this will be available as an open standard to any groups. Tabloids can do it, news people can do it, bloggers can use it. Anybody will be able to use these technologies to add provenance around what they create. It's still going to be up to you to decide whether you believe those people. And the way that this is going to work at a high level is basically there are going to be a set of assertions about an image or a video. I'm just going to go with an image for simplicity. And these assertions may be about the person who created it, the GPS location where it was taken, any manipulation techniques that were performed, what tools you used to create it. Basically anything that can add value in helping somebody understand the image and the backstory of the image. Then what you will be able to do is create hashes of all those claims, or hashes of all those assertions, and create what's known as a claim, which is a digital signature of those assertions. And there can be multiple claims per image. If an image goes through multiple hands during its processing, there can be multiple claims within the image that contain these assertions about the history of the image. And then the most recent claim is going to be embedded in the XMP field, and that will help the software backtrack all the assertions and the claims that are embedded inside. The standards are there to say how to generate these things, the crypto involved and the structure. They are not currently mandating it that any sort of specific assertion be included. That's up to the person at the time they generate it, and I'll go into why in just a second. But this is a visual picture of how this would work. You create the asset, you would have your assertion stores. Maybe it's you include the thumbnail of the original image so that someone can compare the original image with the final image and better be able to discern the changes that occurred with that image if you're changing something that was already created. All of those will be turned into hashes and go into a JSON claim structure. You will sign the claim and it will get stored back into the image with the most recent claim being referenced in the XMP block. And this has actually already been implemented in the field. So USC and Stanford University did a joint project on data integrity called the Starling Lab. And one of the projects within that lab was known as the 78 Days Project. And with the 78 Days Project, goal was to send Reuters photographers out into the field and capture the 78 days of transition between the Trump presidency in the US and the Biden Biden presidency. So they would go out every day, they would take photos, those photos would be put through the CIA system to add provenance to them and to make sure that they were digitally signed. And then we would have this photolistic journal of the 78 days of the transition. And on day 64 is when the Capitol riot occurred. And you can imagine how it would be important to have trustworthy photos from that event. One, for history purposes, as people write books and do the history of this event, you want to make sure that you're using actual photos from the event, not a meme that was shared online. And if you've been following the arrests, a lot of the arrests have been based on photo and video evidence. So having provenance around those photos and videos could be useful for proving that the person was actually there. And once these photos were taken, you could go to the Starling website, and you could click on an info button on one of those images, and then that would display all the metadata that was captured within the claim of all the assertions within that image. So you can see who produced it, what it was produced with, and the time it was taken and produced. So you would automatically have the backstory of that image available to you when you go through their journal and you look at these images. And one of the things you may be thinking about is like, well, okay, but isn't there a chicken and egg problem, right? Like, what if the image was manipulated prior to someone doing a digital signature on it? And how would you know how that image was manipulated prior to the signature being applied? And that's where you may have seen the logos of groups like Intel and ARM joining the C2PA Foundation. And that's because we're getting the assistance of chipset providers to help with this problem. And Qualcomm was the first one to create a CAI compliance camera for a smartphone. So they did this with the Qualcomm Snapdragon 888. So the way it works is Qualcomm's able to support hardware secure photo capture. So the Qualcomm processor security can confirm the device's identity with Qualcomm's wireless edge services. And then the image signal processor is responsible for secure image sensor data acquisition. And then it works with a mobile application from a company called TruePic to be able to embed that metadata into the image as a claim. So we're actually starting to see the first hardware out there that will be able to support CIA images. And like I said, this could be very important in trials because one of the things that was listed in the American Bar Association Journal article was concerns about just the threat of deepfakes, how that will bias jurors during a trial. And they look back to what happened when CSI, crime scene investigation shows, became popular in the US. A lot of people watch those TV shows and they assumed, okay, well, this is how crime scene investigation happens. You go into a room with a fluorescent monitor with touchscreens, and there's all this effort that they're able to put in with a full squad investigating every single crime. Well, after people watched those shows and then they went into an actual jury and they saw how crime scene investigation actually happens and it didn't match what they saw on TV, they would sometimes just acquit because they were expecting what they saw on TV. And with deepfakes, as we get this distrust generated within society that the Adobe research reflected, we may see the same thing where every single piece of image and video has to be contested and there has to be a forensics background for it. And so you would want to have secure image acquisition. Another thing that you may be thinking about is, I mentioned identity. And identity is always a very tricky problem to solve. One of the problems that CAI has is that we want to be able to support photojournalists that are in at-risk areas. So if you're photojournalist that's out there and you're documenting this atrocity, you want to have your images be believed. So you would want to have some provenance around it to prove that the image was taken at this time and at this GPS location. But as an at-risk journalist, you may not want your personal name associated with it because the government committing that atrocity may try to arrest you or kill you. So the system needs to be able to support anonymity or potentially pseudonyms if you're a pseudonym-based artist. There's also the problem of name collision, right? Lots of people have the same name. Just putting someone's name in an image may not be good enough because you need to know specifically which of the many individuals on the planet that have that name we're currently speaking about. And Twitter tries to do verified accounts, but even that doesn't scale well. So what we've been looking at is decentralized identifiers. And there's a bunch of different programs in this space. There's DIDs, there's WebIDs, there's OpenID, there's ORCID. And they all work around this idea of self-sovereign identity and decentralized identity. So the goal would be with a decentralized identifier is right now you probably use some federated identifier. You log in with your Facebook or you log in with Google, and that has some privacy risks associated with it, and that those groups can see where you're logging in, et cetera. And with a decentralized identifier, it puts you in control of your information and your digital identity, and basically tries to create a system that's decoupled from centralized registry and identity providers and certificate authorities. And it's basically a key value database, very similar to a digital wallet. Microsoft has released Project Ion recently. That came out this year as an open layer 2 decentralized identifier network that runs on top of Bitcoin blockchain. So Microsoft, as well as several other companies, have been actively pursuing this space. As they develop and they become more mature, we will probably try to incorporate those into CAI in order to help with the identity problem, so that if you're using both a Microsoft toolkit and an Adobe toolkit, you can have the same identity in your work across 2 different platforms. Which also brings us up to the idea of blockchain, right? So whenever a new technology comes around, it's like, but how does blockchain solve that problem? And blockchains can help. Blockchains were a part of the 78 Days project that the Starling Lab worked on. And it's also a part of the Project Origins design, where they have their distributed ledger that's available. So they are an option that can be used, but it's not currently mandated by the specification, right? So the specification says how to do things in a general sense, but different implementations of those standards may do things slightly differently. So it is an option. The other thing that comes up is this sounds like a lot like NFTs, because NFTs are crypto blockchain-y image project. And this isn't the same as an NFT. An NFT is there to tell you who bought and sold an image, but doesn't necessarily tell you who created it or when it was created or any of sort of that provenance information. NFTs could definitely have CAI information embedded within it, and so it could be complementary, but it's not going to be the same as an NFT. It would just be something that someone might choose to include in an NFT, and so we're looking at that. And then finally, there's the question about, okay, we make all this technological data available. We've got all this fancy crypto. There's blockchains. There's digital signatures. How are we going to actually explain that to somebody about what's going on? And I included this screenshot not because I'm trying to call out Google. Actually, Safari had already implemented the thing that Ars Technica is talking about with Google here. But this is more speaking towards the general history of trying to communicate complex technical information to your average end user and your average consumer. If you look at the history of the address bar, we have over a decade of manipulations to it, just trying to express the simple fact of where somebody is and whether they're at that location securely. So we went through multicolored locks, then we were changing the background of the text so that would be a complete yellow bar when it was secure. But then we decided to get rid of that and gray everything out and only block when there was a problem. But we still wanted people to know where they were. So we made the domain names bold. And then, that kind of worked, but they wanted to be able to improve on it. And so now we're at this place where, browsers are just thinking about, okay, we'll just hide the URL path altogether and just tell you the domain. So it's been this really iterative process of trying to be able to communicate to end users this very simple thing. And when you're dealing with deepfakes and provenance, that's even a whole other level of user education that has to be provided. And how do we communicate this information to end users? And you may have noticed in the Starling Lab example, you could get that additional provenance information by clicking on an icon within the render space of the web page. And if you've done trusted UI, you know that sometimes there are risks associated with trying to convey trusted information within a potentially attacker-controlled space. And so Project Origin, because it's backed by Microsoft, and Microsoft makes a browser called Edge, one of the things that they were looking at is, well, maybe we take it out of the web page and we put it up in the location bar as an icon within the browser, so that the trusted UI actually comes from the browser itself and not from the web page. So there's a bunch of different things that we're experimenting with in terms of trying to how to communicate this information to an end user. It's going to be one of the problems that we need to solve that can only be solved by multiple betas and working with end users and trying to see what resonates with them. So over time, looking at the roadmap for Project Origin and CAI and C2PA, a lot of this stuff is going to be coming together as we go. We have Qualcomm, who's generated the first hardware compliant chipset, but we need more of those. So we'll obviously be looking at the new ARMv9 Realm features that are coming out with ARMv9, as well as working with Intel. Decentralized identities are still becoming a thing. And as those come on board, we're going to be trying to onboard them. And we're basically going to be, working our project in parallel with these other initiatives, because, deepfakes are causing a lot of concern in society. It's getting a lot of media attention. We need to be able to make sure that we're actively working to get something out there that will work. And that's going to take lots of iteration. So we're starting now. So hopefully we'll be where we want to within a shorter amount of time. So Adobe is going to be launching a CIA implementation. It's a public beta later this year. There will be a version of Photoshop which is able to support this. In addition, the standards within C2PA are being actively developed. They're going to be linked to from the website. There will be a GitHub project similar to W3C standards, where these standards are being developed. You'll be able to view them. You'll be able to see how they are being developed. And we're taking the approach that is very similar to what you see in the browser community, where we're getting some implementations out there before we finalize the standard, and so that we can get real world feedback before we make final decisions on the standard. That worked pretty well in the browser community, and we're doing a very similar approach here. And there's going to be ways that you can help. I would encourage you to join or follow the C2PA or CAI initiatives. We're constantly putting out blogs about what's going on in the deepfake world and things that we're seeing, and both within CAI as well as in general. Project Origin is going to be a good resource if you're actually working the media. But we're going to need you to help test these things out as they go. So as a security researcher, there's all sorts of places you can inject yourself. So if you're a hardware hacker, your ears probably perked up when you saw what Qualcomm was doing with secure hardware photo acquisition. And so maybe you help do research in the hardware layer of this problem. Obviously, we're going to be making changes to the browser and to desktop applications like Photoshop. So there'll be stuff for desktop people to look at. All of these things are going to talk to web services and to blockchains. So for your web app pen testers, there'll be something to go take a look at as well. And if you're a machine learning person, you could obviously continue to build on machine learning research around being able to detect these things. And then as these things become available, we hope people actually use them. If you're an average consumer, the BBC Trusted News Initiative recently did a Beyond Fake News conference where they put together information both on how journalism are seeing the fake news world, as well as resources for consumers to be able to look at media and be able to discern whether or not it's true or not. So those are resources available to technical and non-technical people alike. So with that, I'll go ahead and link to a couple of resources of several of the things I talked about. And at the bottom, I also linked to example websites such as This X Does Not Exist. That is a website that does a bunch of GAN-generated deepfakes. And you can kind of see what the quality is like. They have this human does not exist, this cat does not exist. The UI is a little bit weird to keep having to hit refresh manually, but it does actually show the quality of deepfakes that can be generated today. It's one of the models that people use when testing their machine learning algorithms. And then a lot of people like watching the deep top cruise examples on TikTok as something to go out there and see actual video that people put effort into. So some of the deepfake Tom Cruise videos, they trained their models for 2 months and then used actual professional Tom Cruise impersonators to try and make sure that the machine learning had to do as little work as possible to generate a deepfake of Tom Cruise. So if you want to reach out to me, you can hit me up on Twitter or LinkedIn or via email. I'll probably be writing some blogs about this topic as well going forward. But with that, I'll go ahead and just go ahead and switch back to the resources slide, since I think it's easy to find me online, but these things may be harder to find. With that, I'll close the talk and see if there's any questions. I currently can't hear you.
Got to get rid of all the mutes before we can actually talk. Too many mutes. Oh, good. Okay, so I'm coming in on your audio on the AirMeet now. That's awesome. So that's still fine. Thank you very much for that. Cut over here, and we'll get rid of some things on the stream, and we'll just get ready to stay out. Let me just say a couple of final words. That was an amazing talk. Your stage background gives you a good presence on site, and that was fascinating topics. I'll just be real brief because this is really the first talk of 3 weeks of an unconference where we're doing sessions on Tuesdays, Wednesdays, and Thursdays, midday on Tuesdays, early morning for Europeans on Wednesdays, and late night for Asian presenters on Thursdays. We're planning on having a party next week with some pretty spectacular visuals and some cool DJs. This will all be held in our GatherTown social track, which is kind of like a hallway area. We're going to be putting these videos up. We're going to be having a little showcase, and people can drop in on it and get all the conference videos from there. And we're also set up, and we'll be doing the sessions on a new platform called AirMeet, which has a kind of table metaphor where you can sit around tables outside a session and talk to people. So brave new experiments in online interaction await us for the rest of the week. Thank you very much for kicking that off for us, Peleus. And I'm looking forward to the next time when we can actually hang out and have drinks in person at Whistler or somewhere in Vancouver, hopefully next year, because I miss you guys terribly. So with that, I'm going to shut off the streams, and we'll take things over just to the AirMeet and talk to folks there. So bye, folks. If there's some audio glitches or anything on streams, don't worry, I'll fix it, and I'll repost cleaned up ones shortly later today. See ya.